Is the tide finally turning? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 6th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you would like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. B. Nadine, Our Predicament, Evolution Moto, not once but twice, Clay Goose, and Ken NCal. Thank you all so much. I really appreciate it. With that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting North Pacific, a little bit of a gale off of Kamchatka, producing 20-foot seas and remnants of another gale. In the Gulf of Alaska, producing 17-foot seas. Swell from when this system was stronger, you can see passing Hawaii and hitting the U.S. West Coast. Down the South Pacific, a gale with 38-foot seas is developing now. This is east of the Southern California swell window, so it's targeting Chile, Peru, up into Central America and Mexico, but probably will not reach up into California. But still pretty sizable, especially considering the time of season. Looking into the North Atlantic, we have a gale with about 27-foot seas targeting Morocco up into Portugal. And down in the South Atlantic, a gale pushing under South Africa with 36 roughly foot seas, probably targeting more spots into the Indian Ocean. And then here into the Indian Ocean, another gale with 30-something foot seas, 31 or 32 foot seas. And then some stormy weather under Australia, but nothing of particular significance, at least not yet. But before we get into all that, let's just go zoom in and look and see what's happening right now, current conditions. We're going to start up in the Pacific Northwest off the Oregon-Washington border, the Columbia River area, Grays Harbor buoy, number 036. Yes, we're looking at the buoys. They give us an indication of what's going on in the ocean. This graph here depicts all the energy that's currently hitting that buoy, all the way up from 33.3 second period, really long period energy, which there is a little bit at 0.1 feet, and then the whole way down to 5 second period, just pure chop, and there's a little bit there, but you can see where the spikes are. That's where the balance of the energy is. This is in feet, and there is some sort of a swell hitting with 13 to 14 second period energy. You see right here, and then another little bit of wind swell at 9 seconds, but it's not just, a swell is not defined by this one slot here. It's energy on either side of the shoulder, and you see the shoulders kind of overlap, so the algorithm has a bit of a chore trying to tease out what is one unique swell from another. Anyway, using that, primary swell estimated 5.3 feet at 14.4 seconds from 262 degrees. Theoretically, that would make surf at 6.7 feet. That's not like it's some swell-enhancing bathymetric break. That's just like your standard ordinary beach break. Good bathymetry can almost double this size. Then secondary swell 4.6 feet at 10.3 seconds, theoretically adding a little bit more energy in at about 4.8 feet. And then this chop height thing, 1.5 feet, that's just all the energy between 2 and 5 seconds. It gives you a rough guess on how jumbled up or how, churned up the swell is. 1.5 feet, not much at all. Once you get over about 2.5 feet, though, things get dicey, and when you're in the 3-foot range, forget it. It's not really surfable. Then we come down to Northern California. The Point Reyes buoy 029 off of Point Reyes, California, just north of the Golden Gate. Same sort of profile exists. More energy, though, in the 16 to 18 second period range. Another little blip at 13 seconds, another at 9 seconds. So there is swell in the water. Primary swell 4.2 feet at 17.4 seconds from 282 degrees. Gets you surf at 7.4 feet. And then secondary swell, 5.5 feet at 13.4 seconds from 269 degrees, gets you about another 7.4 feet of surf. And waves are, overhead, well overhead as of this evening. Then we head to Southern California, the Point Loma South Buoy off of San Diego, buoy number 191. Now, the swell has not reached down into Southern California, and there isn't really any meaningful southern hemi swell, so you can just see here it's every single reading is below 1 foot. This will be a tough tease out here. Primary swell 0.9 feet at 17.2 seconds from 209 degrees. That's surf of 1.6 feet. And then secondary swell 0.7 feet at 20.2 seconds from 189 degrees. I don't know. Let's see. Oh, I see a little bump at 17. I see a little bump at 20. Yeah, I see what the algorithm is trying to do. It's having a really hard time there. But needless to say, surf is pretty small. We go over to the north shore of Oahu, the Waimea Bay buoy, number 106. Now, we do have swell there. It's filling up the whole range from like 12.5 seconds up to 16 seconds. This is the same swell that's just starting to hit Northern California now. This swell also will be working its way down into Southern California, but attenuated somewhat by the Channel Islands. Let's see how the algorithm does here. 7.5 feet at 15.6 seconds from 344 degrees. That makes surf at 11.6 feet. And then secondary swell, 7.2 feet at 12.3 seconds from 337 degrees. That makes surf 8.9 feet. So let's see, 15.6, 12.3. Wow. Algorithm did pretty good there. I'm surprised it just didn't lump all that together in one big pile, but not bad. All right, now let's go take a look back over the past week. We're looking at what is happening, the balance of power, whether it's in the northern hemisphere or the southern hemisphere, or whether it's in one particular ocean versus another. All right, so we're into Sunday last week, the 31st of March, into Monday. Southern hemi looks like it's doing pretty well, probably most energy until you get to Thursday night, Friday, the 4th of April. Nice gale developed here in the northern hemi. We'll discuss all the details of that in a minute. And then that continued on and then faded out. Another system firing up as we're getting into Sunday, the 6th of April today in the North Atlantic. But again, the balance of power seems to be shifting to the southern hemi. All right, so let's drill down. We're last week, Sunday, the 30th of March. Little gale developed off of California, but for the most part, it was a rain, not even really a rain, a snow producer in the Sierra. Cut off low northwest of Hawaii, didn't really do a whole lot. And then we got into Thursday. A gale started developing in the Gulf of Alaska, producing 20-foot seas initially on Thursday morning. But by the evening, we had 29.4 feet right there. That's the highest seas over this entire domain, the location of those seas. Then the max winds over this entire area, 47.7 knots. Now, this is per the model, right? So not always completely accurate, but it gives you a reasonable representation of what's going on. So we got into Friday, seas pushed up to 33 feet, aimed a bit east of Hawaii, targeting the U.S. West Coast more. And then Friday night into Saturday, the gale pushed east and took aim better at the U.S. West Coast before finally fading out on Sunday. And here we are, current predicament. Then we go to the South Pacific. There was a little gale here in the mid-upper reaches of the South Pacific with 29-foot seas. Another gale south of New Zealand with 31-foot seas. Those both produced very tiny swell that is working its way north up into California. Not really so much at Hawaii. That swell will be hitting during the early part of this week. And then, let's see if we can pick this up. And then a real gale developed starting Wednesday night, the 2nd of April. 29-foot seas building to 31 feet, another 31-foot reading. So we got into midday Thursday, 31 feet, 29 feet. And then it rebuilt on Friday. Now, the cutoff for Southern California is about 117 west, so right there. Unless by some miracle a storm is producing winds that produce swell that goes to the northwest. So in general rule of thumb, 117 west. Seas anyway to 32 feet, building to 34 feet, and 120.8 west. And that was pretty much it at 117 west and that system was out of the California swell window. But swell from it, you can see, pushing its way north, bound eventually for all of North Central California, Central America, down into Peru. Now, this gale, or remnants of the gale, redeveloped this morning with seas 35 feet. I think we have one more reading here to 38 feet. Now, this east of the California swell window, but targeting Chile, Peru, Central America, maybe up into Mexico. So something to look forward to. And if the North Pacific, not going to be so active, it seems like the Southern Hemi is definitely coming online. Now, going back over the past week for the North Atlantic, yes, there was a gale last week up here off of Ireland with 37-foot seas, but that pretty much impacted Iceland, and that was the end of that. Another little gale developed. There's kind of this permanent trough off of Portugal and Morocco. 24-foot seas building to almost, there we go, 26-foot. This was on Tuesday night, the 1st of April, and then it faded out. Of course, swell from that has already come and gone. Another little system following in the same tracks with 27-foot seas. This would be on early Saturday morning. And then more energy behind that with 29-foot seas today, building to 30 feet. Again, targeting Morocco up into Portugal. And that is the current scenario. To the South Atlantic over the past week, we'll run through this. Probably not as energetic a pattern. There we go, 29-foot seas. Oh, I spoke too soon. 33-foot seas, 34-foot seas. This was on Thursday morning, passing south of South Africa. You can see the leading edge of, now most of the energy aimed off to the east, but South Africa is pretty well to the south. So you can see sideband energy impacted there on Saturday, the 5th of April. And another little system developed right behind that with 36-foot seas. Now, it looks like most of the energy is pushing into Antarctica, but again, some sideband energy likely is going to push north into South Africa. And then finally, the Indian Ocean. We're back a week ago, Sunday, April 30th. Small system here southwest of Australia with, 29-foot seas. And then some more generic 20-foot sea sort of situation. A new system developed Saturday south of South Australia with 28-foot seas, and then that same group of complex gale system pushing under Africa, bound for the Indian Ocean. All right, looking forward, we're going to do a deep dive into the North Pacific. It seems like this might be one of the last deep dives for the North Pacific. We'll switch to the South Pacific, but for right now, we'll do it, if nothing else, for old time's sake. This chart depicts jet stream level winds. Those winds are up about 30,000 feet. They help support the formation of gales. When those gales form, the jet stream helps direct their track. We're looking for a trough, a dip in the jet to the south. You see that right here. What that helps do is create a counterclockwise flow or an eddy in the upper atmosphere, but that also helps manifest itself down at the ocean surface. That is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, creating seas. Those seas, as they radiate away from the fetch area, the lesser period elements decay away because they are weaker and have less energy, exposing the longer period elements of what eventually becomes a swell. And that swell, of course, when it hits your beach, turns into surf. So the jet stream pushing off Japan, but you see one branch going way up here into the Bering Sea. The main branch, tracking about like what you'd expect on the 45 north latitude line across the Pacific, and then yet a weaker branch way down south here. It seems like the jet is getting a bit unraveled, not a big surprise given the time of year. Put this into motion. See that trough pushing onshore into Washington as we get into Monday, maybe creating weather there. And then you have the same sort of pattern, but see the jet start digging out again on Tuesday, April 8th, north of Hawaii, trying to create a trough, but there's not. Let's go back and look just for a second. You have 150 knot winds there for a moment, literally like 12 hours. Those winds fade out. I don't think you're going to get a gale out of that, maybe some low pressure. Then we continue on. The jet still, look at this, split all over the place. You really want to see one consolidated jet. We're into Friday. Another little trough tries to develop off of Washington. Another trough over the Dateline region. Winds not particularly strong, and the jet not looking particularly well organized. We're into Saturday, the 12th of April. Then here we go, yet another trough west of the Dateline, another one in the northwestern Gulf. And they continue off to the east, maybe offering some hope, but in general, the jet just kind of weak and meandering around and not super energetic. I mean, it's springtime. What would you expect? But so let's go take a look down at the ocean surface. It is actual winds blowing on the ocean that impart energy to the ocean and create seas and eventually swell. So we need to see winds, and for a 13-second period swell, you really want to see winds 35 knots or greater. Looking at the color bar here, you can see the scale, but basically this is all 25-knot fetch here, not really doing a whole lot. Maybe good for wind swell, but as far away as it is, that isn't even meaningful. I mean, real wind swell is like within 200 miles of the coast, and all this is thousands of miles out. Anyway, okay, off Japan, you're into Monday night. Gale tries to organize here off the Kuril Islands, quickly just sputters out and disappears. Another gale tries to develop off of California Wednesday and Thursday. It doesn't do anything either. And then we're into Friday. Now, a semi-legit gale forms over the North Dateline region on Friday, the 11th of April, with 35-knot winds targeting Hawaii, building to 40 knots briefly there, so maybe some hope for that. I'd say for Hawaii, maybe producing some sort of a swell. You see bits and pieces of other gales that if it were September or August, I'd be going, oh, maybe there's some hope here. But, I mean, we're just at that point where energy is dissipating from the northern hemisphere. It's beginning to be or moving towards winter in the southern hemisphere, and that's where you get that big contrast of temperature, warm temperatures and cold temperatures. That's what really feeds the development of gales along with the jet stream, and that's what makes surf. All right, so what are the effect of those winds on the ocean surface? We need seas. We need seas at least bigger than 20 feet to produce any meaningful swell. We don't see that. What's the 20 foot? It's like the that light kind of orangish color. So we're just going to blast through this because, well, there we go. A little bit off Japan, but way too far away, not doing anything. Looking for some sort of, there we go. And then finally on Friday, 18Z, the 11th of April, little gale with 23-foot seas, not even over the dateline. I mean, there'll be minimal swell for Hawaii from this if it materializes. At least it's falling to the southeast, targeting Hawaii pretty well. So maybe one last little blast of semi-real or at least rideable swell for the Hawaiian Islands to result. Otherwise, nothing for the North Pacific. Going to the southern hemi, we do have a solid gale with 38-foot seas, now again east of the Southern California swell window, so this is all targeting Peru and Chile and Central America. That system pretty much fades out as we get into Monday, the 7th of April. We're looking for something, another gale forming east of New Zealand on, we'll call that Tuesday night. Let's actually run this back. Little bit of, if first gets traction on Tuesday morning, what's that, 22 or 23-foot seas, then hits the 29-foot sea mark on Tuesday night into Wednesday morning. Now, it's not pushing to the northeast, it's pushing off to the east, but you can get a general sense the fetch is out of the south. So some decent swell should probably result for Tahiti. Where's Tahiti? Somewhere right around in here. Maybe up into Hawaii. Yes, it's west of the Hawaiian cutoff, which is about 158 degrees. So maybe some hope there. Then another system is forecast pushing under New Zealand on Friday, the 11th of April. Not looking particularly good. This morning's run of the model looked a little bit better. Tiny area, 33-foot seas, but that's all running off to the east. Doubtful anything yet will come from that, but the models can change, and hopefully they will in our favor. Up to the North Atlantic, there is currently a gale sitting right smack in the middle of the North Atlantic, producing 26 to 28-foot seas, targeting Morocco and Portugal. that system fades out. You can see swell energy from it radiating off in all directions. And then after that, well, we're already to Friday, Saturday, the 12th of April, and then really nothing. It definitely seems like the seasonal transition is underway. To the South Atlantic, paragales pushing off into the Indian Ocean. A little bit of energy perhaps for South Africa from that. Another system tries to get organized due south of South Africa, 29-foot seas, some background energy, but again, it's not aimed really well to the northeast. Here comes a little bit better of an angled system. Again, only 29-foot seas. This will be on Saturday, the 12th of April, and that takes us out to 180 hours. Then finally, the Indian Ocean paragales. We saw that before, pushing into the Indian Ocean. Certainly some swell background, so you can see a leading edge of some sort of increase in sea heights. That's probably from swell energy, working its way off to the north, up towards Bali, Indonesia, Western Australia. You get the idea there. But is there anything more behind it? Maybe a tropical system here, but there we go, 29-foot seas on Sunday. This is a week out. Really no major play in the southern Indian Ocean just yet. A quick look at local winds for California. So Southern California down here, Central California, there's the Bay Area, North California up there, and the Hawaiian Islands here. What we're really looking at, not so much because there's some massive swell happening, but what we're looking for is hopefully not the development of strong high pressure and strong, it would be northwesterly winds for California, or abnormally strong trades for the Hawaiian Islands. That creates upwelling, drops water temperatures down, and that unusually strong high pressure system that would make those winds is an indicator of La Nina in the atmosphere. We do know there is a weak La Nina in the atmosphere, but we don't want to see some massive big blow event going on. All right, so we're into Monday. Pretty light wind regime for California. You do see high pressure out here. Low pressure up in the Gulf of Alaska. Trades 15 knots out of the east-northeast for the Hawaiian Islands. We get into Tuesday, pretty much the same sort of pattern. Trades backing off for the Hawaiian Islands. Wednesday, here comes some high pressure, northwest winds, 10 to 15 knots for California. Trades northeast at 10 knots for the Hawaiian Islands, but you still see low pressure up here. I mean, not unusual for this time of year. We're sort of in that transition. So we get into Thursday, the 10th of April. Again, still a reasonably light wind regime for California. Trades 15, 20 knots for the Hawaiian Islands. Friday, same sort of deal, but you see now here comes the high pressure moving into range, starting to ridge up against the coast north of Hawaii. Trades 15 knots. Northwest winds, which are really trades for this time of year for California, about 15 knots. Friday into, we'll just go right to Saturday, 20. Here's your strong northwest wind event. Now, great for making local wind swell at protected breaks, but that will drop temperatures some. But pretty much means we're going the whole way through the week before that sort of strong northwesterly wind event starts happening. Trades 15 knots for the Hawaiian Islands. We're into Sunday, a week from now. Still 20-knot northwest winds for the California coast, but that is not really unusual. Trades light, 15 knots, maybe 10 knots for the Hawaiian Islands. And you already get the sense this fetch is going to start fading. And what you want to also see relative to California is if there is fetch, that it's more up here rather than down here. The stronger the average high pressure system here, the more the northwest winds get confined down to the Point Conception area. The better mode is the northwest winds up here at Cape Mendocino. That lightens up the wind speeds along the coast here. You get the wind swell without all the upwelling and the cold water, and at least you get some wind swell out of it. Precipitation forecast for California, Southern California, Central California, Northern California, a little bit of a weak front here over Cape Mendocino. So we get into Monday, maybe some rain as far south as, I'll be generous and say, Santa Cruz. That is first thing in the morning, but by 10 a.m. it's all gone. And it shows a little bit of rain there up in the Sierra as well. I'll call it showers, and it did not indicate any snow. After that, we're into Thursday, Friday, Saturday, Sunday, it certainly seems like after the good dump of snow, and I don't remember the exact amount, I saw the models at one point forecasting 54 inches for the Tahoe area. I think the final totals were more like in the 42 to 48 inches. We were up there on, when was that? Monday, Tuesday, Wednesday of last week, and it definitely dumped a lot. Super good quality snow. Actually, I would say at some select resorts, it was the best snow of the winter, mainly because it's been so warm and it's been raining at the base of many resorts, but it was full on snow the whole way to the bottom over that day, and it was not as dry. It was wet enough, but it actually stuck to what was a pretty bulletproof base. And within 6 hours, it was totally skiable and great, and it only got better from there. So, but I would say that's probably the end of the rain and snow for this season. The snow forecast dashboard for Palisades Tahoe, formerly Squaw Valley. You see nary a drop of snow. I'm not even going to go look at any other resorts because if it isn't going to get it there, everything else is further south of there and they're not getting anything. Freeze levels. Here's the next part. This is the base of Palisades Tahoe at about 6,200 feet. This is the summit up at 9,000 feet. Reds are, if there were precipitation, it would be liquid precipitation. This is like 35 degrees or above. The gray is sleet. The 32-degree freeze line is right at the interface between the gray and the white here. The blue, 28 degrees or below. So you see, yes, freezing temperatures, not even to the base, just down to about mid-mountain on, what is this? The evening of the 7th, that'd be Monday evening, but then you see the freeze level the whole way up at 12,000 feet. It makes another little venture south down to about mid-mountain on April 12th. And then the same sort of thing. So you see maybe cold front there, cold front there, cold front there, but none of them producing any precipitation, much less even no freezing precipitation. So snow season looks like it's over. Spring skiing coming. Nothing wrong with that, though. Corn snow is the bomb. All right, so let's go take a look at the surf forecast for a couple select locations. We'll start up at Columbia River area up there, North Oregon. Surf heights in the 13-foot range on Monday, swell currently hitting there, but you see generally working their way down. You can look at wind speeds and wind directions, 20, 25 knot winds. This was on Tuesday out of the south, so some cold front coming through. After that, surf heights in the 5 to 6 foot range, and maybe up to 9 feet on Sunday. So maybe some opportunities there. Winds out of the south. Find your selected, select protected locations. Swell heights was 7 feet at 13 seconds. And then a little bit of wind swell mixed in there, 7.5 feet as we get into Tuesday at 11 seconds, going down from there. Then another little bit of wind swell in the 6 foot at 11 second range, 8 feet at 11 seconds. So no big death long period swell anymore. Surf for mere mortals. Then going down to San Francisco, Ocean Beach, San Francisco. Surf heights 12 feet as you get into Sunday night, fading into the 9 to 10 foot range Monday morning. Slowly working their way down through the week. You see northwest winds trying to pick up, but not really too bad until you get into next weekend, and then it's northwest at 25 to 30 knots. Surf heights, it's all probably locally generated wind swell in the 3.5 foot range. Let's go look at actual swell sizes. Peaking out Monday, early morning, 7.8 feet at 15 seconds, working its way down through the week, down to 4 feet at 10 seconds. And then southern hemiswell, and 2 feet, 2.5 feet, roughly at 16 to 17 seconds as we get into next weekend. That sure is the transition from north swell to southern hemiswell, really putting a fork in the fact that the seasons are changing. To Southern California, San Diego, a little bit of that swell, the northwest swell trying to work its way in, 3.5 foot surf. And then I think there's some jumbling going on here between wind swell and actual swell. And then things come up a bit as we get into Friday and Saturday with surf heights in the 4.5 foot range, all that southern hemiswell. At least that's my guess. Let's go take a look here. Here's our main swell, 2.5 feet at 18 seconds. It gets overridden by 2.5 foot at 8 seconds, just like a westerly wind swell. Then the final bits of the swell finally makes it back in the graph in 1.5 feet at 11 seconds. Then here comes the southern hemiswell, 1.6 to 2 to 2.7 feet at 16 plus seconds. And then it gets overridden by wind swell 4 feet at 9 seconds or so. The North Shore of Oahu, really don't have to look here, but just because of all of what we've seen already. But our main swell here in the 15-foot range on Sunday, fading to 9 feet on Monday, 5.5 feet on Tuesday, Wednesday, 3.5 feet. Then after that, it's pretty much over. Trades pretty brisk in the 20-knot range from the east-northeast, pretty much the whole way through the next week. And a quick look at Tahiti. Surf heights in the 6 to 7 foot range, maybe early Monday. Slowly dropping down. That's probably sideband energy from one of the swells that's working its way north. And then really nothing. Then building again to 6.5 to 7 feet as we get into the weekend. Swell sizes, 4 feet. Here we go at 14 seconds from the south, down to 2 feet at 11 seconds. Another little background pulse in here at about the 1.5 to 2 foot range at 12 seconds. Then a little bit more substantial into the 3 to 4 to almost 5 foot range at 14 seconds as we get into the weekend. And a quick stop over in Bali, Indian Ocean, surf heights in the 5 to 6 foot range for the early part of the week, fading off, then building back up into about the 4 foot range. And then as we get into the weekend, coming up, pushing to 10, if not 11 feet. Winds generally light, depending on where your break is. Swell heights, 4.9 feet at 12 seconds from the south, fading midweek to about 2, well, then bumping back up 3.5 feet at 14 seconds, and then building to 7 feet at 15 seconds. So you get the sense, a steadily building swell pattern for the southern hemi as the northern hemi starts to go to sleep. So that brings us to the long-term outlook portion of tonight's discussion. We're going to examine the two major weather oscillations that affect the potential for storm and therefore swell production. They are the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We start by talking about the MJO, the Madden-Julian Oscillation. There are two phases, the active phase and the inactive phase. The active phase is our friend. It is like a low-pressure system. It takes warm, moist air down at the ocean surface, lifts it aloft up into the atmosphere. That feeds the jet stream, be it either in the northern or the southern hemi. And that energy makes the jet stream stronger. A stronger jet stream is more efficient at creating troughs and therefore feeding storm production. The inactive phase, the jet stream is like a high-pressure system. It has downward falling air, and it cuts off the flow of moisture up into the jet stream, make it weaker and split. Now, the active phase and the inactive phase are always in play, rotating around the planet from west to east on the equator. So when the active phase, if you're in the Pacific Ocean, when the active phase moves into the West Pacific, that is a good thing. It starts feeding the jet stream, and then you start getting more storms. And it takes about 5 to 6 weeks for the active phase of the MJO to move from the West Pacific to the East Pacific. But it is when the active phase is in the West Pacific, for about a 2-week window, that's when it is most efficient at feeding energy into the jet stream, because it's up, well upstream of where you are if you're in the United States or in South America or something like that. Once the MJO pushes, now it's on the equator, right? But once it pushes parallel or perpendicular to your location, then what it's mainly going to do is make weather in your area. But the potential for storm, for meaningful swell producing storm activity diminishes significantly. And of course, the inactive phase does the exact opposite. When it's moving over the West Pacific, it sets up high pressure, splits the jet stream, and then you get kind of no surf. And if you ever follow the models for any length of time, you get these pulses where you get storm cycles, be it in the southern hemi or the northern hemi, where you get storm after storm after storm for a couple of weeks. And then things kind of back off for a couple of weeks. And then it wakes up again, and that is the MJO at work when, everything lines up and it becomes real obvious. All right, so this chart, this is trade winds. Active phase of the MJO, because it's like a low pressure system. Well, trades are made by high pressure. So if you have a average lower pressure driven by the active phase of the MJO, it diminishes or decreases trade winds along the equator. Okay, so we can use this chart to kind of tease out whether the active or inactive phase of the MJO is in the Pacific Basin. This is data from the TAO buoy array, a series of buoys strung from the East Pacific to the West Pacific, used for monitoring El Nino, but we can also sort of tease out the MJO from it. That's the equator there. Dateline is right there. That's New Guinea there. We're just looking at the length of the arrows. This is actual average wind speed, 5-day average winds. So trades out of the East, but not particularly strong here in the East. In the Central Pacific, not too strong, a little bit stronger over in the West Pacific. But it is not the actual wind speed. There's yet another layer to this puzzle. It is the anomaly. Are these winds stronger or weaker than normal for this time of year? Right? Sometimes a year the winds blow all the time, not so much other times. So looking here in the East Pacific, you look at the arrows, you go, whoa, they're going the opposite direction. That means the trades are weaker than normal over here in the East Pacific. In the Central Pacific, they're dead neutral. In the West Pacific, a little bit stronger than normal. Trades a little bit stronger than normal, but not too strong at all, really. All right, what's the forecast? We actually have a chart from the GFS model, 850 millibar zonal wind anomalies. So this isn't down at the surface. It's up about 4,700 feet. But that's kind of a good thing because down at the surface, you have mountains, you have buildings, you have, anything that can obstruct the wind and it kind of muddles your view. Up a little bit higher, you get a better sense of, are the winds stronger than normal? Are the trades stronger than normal? Or are they weaker than normal? So how do you read this chart? The blue's the purple, stronger than normal trades. You see that and here's the date line right here. This is the whole planet on one chart. The far West Pacific here, it starts about 125 east, so you can just go right up the chart. And it's the West Pacific. I call it the Kelvin wave generation area, from 125 east to about 170 west. That's really what feeds the jet stream, either for the southern hemi or the northern hemi. So you see the blues and purples, easterly anomalies, trades much stronger than normal. There's no this is going back the whole month of March. And you see the reds and yellows, these are westerly anomalies, and they're not doing a whole lot either. Now this chart, it's interesting. This chart, I think last week, showed all these trades just gone about a week from now. Now it has them back out, but it does show westerly anomalies moving from right at the entrance here to the West Pacific to moving halfway to the date line, suggesting, now this suggests to me that we're probably in some sort of inactive state right here, and that we're moving to the active phase, and westerly anomalies moving into the West Pacific? Maybe. Let's dig a little deeper. All right, so digging a little deeper into the MJO part of the discussion here, we're looking at OLR predictions. What is that? Outgoing long wave radiation. What's that? It's basically, is it cloudier than normal or clearer than normal? If you have the active phase of the MJO, it's taking warm, moist air, lifting it aloft. That warm, moist air hits colder temperatures up aloft and forms condensation, and that forms clouds, persistent clouds for weeks on end in a particular area over the globe. Inactive phase does the opposite. It's downward falling air, high pressure, clear skies. All right, so the blues here suggest negative outgoing long wave radiation, meaning more clouds than normal. Yellows, less clouds than normal. And where are we? South America, Central America. There's Hawaii up there. EQ, the equator right there. 180 west, that's the date line right there. New Guinea there, you get the idea. So weak active phase in the far West Pacific, inactive phase building in the Indian Ocean. 5 days from now, no change. 10 days from now, no change. Inactive phase a little bit stronger. 15 days from now, so about 2 weeks out, really no change. Inactive phase fading. Now this is from a statistic model. The dynamic model, kind of saying the same thing. The difference is a little bit of an inactive phase, a little bit of an active phase 2 weeks out. Call it even. weak MJO pattern. That's not particularly unexpected this time of year. The MJO really is its strongest in the fall and the early part of winter. So we're moving into a weaker MJO pattern. Next up, phase diagrams for the same two models. Statistic model here, dynamic model here. How do you read this? The MJO moves from west to east around the planet on the equator, from the Indian Ocean to the maritime continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so in the West Pacific. The further away from this circle the dot is, the stronger the MJO is. And this is active phase only. So very, very weak active MJO in the West Pacific. According to the statistic model, it's supposed to move to somewhere over Africa 2 weeks out from now and be exceedingly weak. The dynamic model has it meandering around and coming back to the West Pacific 2 weeks from now and still incredibly weak. So the models, when you look at it like this, they're kind of really undecided, but they are in agreement on one thing. The MJO is supposed to be very weak. All right, upper level moisture. This is 8 different panels here, 5 days a panel going out 40 days. The oranges and reds would be dry air, the greens, wet air. South America, Central America, New Guinea there, 0 is the equator, date line's roughly there. So this says inactive phase, moving into the Atlantic, active phase, moving from the Indian Ocean into the West Pacific, and fully transiting across the core of the West Pacific into the end of April, let's say. Now, this is upper level, so it runs about a week ahead of what's going on down at the surface. So, month of April, if there is any MJO, this is probably a good month for it helping to feed the storm track. Then you get into May 1st, and then you see the inactive phase making its path across the Pacific. So, a month of active, a month of inactive, at least according to this model. Right, so this one is back to the east-west component of the wind, 850 millibars zonal wind anomalies. This is from the CFS model. It's a long-range dynamic model. Has a bunch of past history from January 11th up to the current date or close to it. It also indicates the MJO, the dotted solid, or the dotted black contours, inactive phase with the blues easterly anomalies. The solid contour, the active phase, notice the cluster of tropical systems around the active phase because it's a low pressure system. But you also notice westerly anomalies never make it into much past the entrance to the West Pacific. Back here in February and March, inactive phase, and then kind of nothing. Here's where we are today. Some sort of a resurgence now forecast of the inactive phase from now out 1.5 weeks. There's the date line right there, and it's gone. Then you see, and this is sort of goes to what the title of the video talks about, is the tide turning? Notice the active phase forecast making its way the whole way across the date line with westerly anomalies probably further than anything we've seen so far this, the entire past winter. So making it at least halfway across the Kelvin wave generation area. Notice, though, the preponderance of easterly anomalies and their fading. This is really the La Nina signal. When La Nina sets up, it's like a permanent inactive phase of the MJO over the date line. When El Nino sets up, it's like a permanent active phase of the MJO over the date line. So you see that for sure, easterly anomalies, dry air kind of thing. But then you get 1-2 weeks out, and the pattern kind of looks like it's going to change. Then we go to the 3-month CFS model. Yeah, I know, you laugh. It's like, don't believe a model out a week, and then we go and look at a model that goes out 3 months, and then we get all excited about it. Then we get depressed when it doesn't do what it says it's going to do. That said, this model in general does a pretty good job. Now things are switched. This is 850 millibar zonal wind anomalies. Past performance is on the bottom. The forecast is on the top. Date line runs right up the middle here, 125 east. That is the entrance to the West Pacific. And just right there, you can see easterly anomalies, easterly anomalies, easterly anomalies, then forecast theoretically a week from now, westerly anomalies making a solid foray into the Central Pacific and at decent strength and building as we get into July. This certainly, and notice the easterly anomalies starting to push off to the east. It's as if there is some regime change that is forecast setting up. Now, those of you that follow this video pretty regularly know that at least I put a bookmark on March 24th of when this transition was supposed to happen from easterly anomalies to westerly anomalies. And now we're probably about 2 weeks out from that date, and we've got about another week to go. But it seems like we are on the cusp. I mean, it's hard to predict local winds with any accuracy 2 or 3 days out. So when you're trying to go months out or weeks out, yeah, there's going to be some fudge factor in all this. Let's overlay the MJO here real quick. Okay, so here is the active phase of the MJO trying to work its way, again, 125 east into the West Pacific, not making it very far. It kind of stalls, and then it gets a second life, literally, let's see, a week. Okay, I'll give it 8 or 9 days from now. And the active phase of the MJO sets up, building to modest status, west anomalies completely filling to the date line 2 weeks from now, and then taking over. After that, notice, inactive phase forecast starting late April, the whole way into the first part of June. But notice westerly anomalies setting up. It's sort of like back here when you have the active phases of the MJO, but they could not get their west anomalies to penetrate across the date line. Now it feels like the active phase is setting up and it's just westerly anomalies, and even the inactive phases cannot shut down the westerly wind machine. And then don't even look at late June and July. I mean, this looks massively impressive, but it isn't going to happen like that. What is going on? All right, so finally we overlay the low pass filter. This really sort of is your La Nina, El Nino indicator. Dotted contour, high pressure bias. So it's La Nina literally hanging right over the date line. You get about 2 weeks out and all of a sudden these contours start collapsing and the whole bulk of the high pressure bias starts moving off to the east, while the low pressure bias, which has been over the maritime continent and Australia in that area, is to start making a foray into the West Pacific about 3 weeks out, and then be completely filling the West Pacific as we get into June and July. This model has pretty much held unrelenting in that opinion. But the one thing here is keep slipping out a little bit at a time, a little bit at a time. We should have already been where westerly anomalies were filling the Kelvin wave generation area. Now we're still a week and a half out, but a week and a half is better than months of knowing you're in La Nina. So for now, I would say the model's doing a reasonably good job, and the demise of La Nina seems imminent. All right, so let's go look for some other signs of what's going on in the atmosphere and in the oceans to give us a clue as to what might be happening. We're going to start by looking at subsurface ocean temperatures. West Pacific here, East Pacific here. Data from the TAO buoy array. Those buoys that are used for monitoring El Nino. The X's right here, here, here. Those are the anchor lines on the buoys. Each individual X is a sensor collecting subsurface temperature water data. And the idea here is to see if you're in La Nina, trades blow harder than normal from east to west. So all your warm water would be balled up over here. If trades start slacking, warm water starts sloshing to the east. All right, so we monitor these isotherms. This is the 28-degree isotherm, 28 degrees centigrade. Last week, I think it was at 173 east and had been holding, ping-ponging around in here for weeks, if not months. Boom, look at that, moves to the date line, suggesting trades are weakening, allowing the warm water to move east. 24-degree isotherm, as it's been the whole way across the Pacific, but last week we saw this too, the 28-degree isotherm building a little bit in the east. Now, it's not actual water temperatures that matter as much as the anomaly, just like the winds. It's the difference from normal for this time of year. You see warm water building here in the west, warm water building in the ice. This is the remnant, or in the east. This is the remnants of La Nina, or what's left of La Nina. 3 degrees centigrade below normal water temperatures at 155 west, so south of Hawaii, on the equator, just limited 5 degrees north and south of the equator, or actually from 2 north to 2 south. Okay, so a very thin band, and little bits of cooler water off to the east. But you see, warm water really has the surface locked down in the east, and the cooler waters are mainly in the west and the central Pacific. We have one other source of data. It's actually, it's the same data. It's the Buoy data, but we also has the addition of satellite data mapped on top of that. And we'll look at that satellite data in a bit. But this paints the same picture. Warming water building in the west, making it to about 165 west. Warming water in the east, and really the only legitimate cool pool anymore is sort of here in the central Pacific. One last little lobe of cool water south of Hawaii at depth, but up closer to the surface, temperatures approaching normal. Here's the satellite data, sea level anomalies. What's that mean? You have a satellite, polar orbiting satellite. Here's the Earth, polar, oops, there we go. Rotates around the planet over the poles, beaming down in a radar. If you know, if it can pull out the wave heights, the tides, the wind waves, and what you're doing is you're measuring the sphere of the ocean. Is it higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contraction, you'll end up with a little divot on the ocean surface. If you have warmer than normal water at depth, it expands, it will displace the water above that warm water pool up, and you get positive anomalies. All right, so what are we looking at here? Chile, Peru, there's the equator right there, Ecuador right there, Central America up here, equator, the date line, New Guinea there. Just 5 degrees north and south, so this little strip here. You see warm water building off of Ecuador. This has been going on for a couple of weeks now, making it, now it's not positive, but the cool anomalies are fading almost to 140 west. The only cool pool we have is these 2 little pockets, minus 15 or 20 centimeters below normal. I mean, that's pretty cold water straddling the equator, suggesting, you have nuking east anomalies right in this area. But then you have warmer water all off here. The dividing line between the two, somewhere right there. If the active phase, when the active phase, this next coming active phase moves over here with westerly anomalies, the idea is it will destroy the easterly anomalies that are feeding this cool pool, and that'll be the end of it. And then we would hopefully return to a normal temperature regime over the Pacific, Equatorial Pacific. Upper ocean heat anomalies. Again, this is using the satellite data and buoys and who knows what else, but it paints a really great picture. This is the West Pacific here, East Pacific here. Blues are colder than normal temperatures, reds warmer than normal temperatures. You see, there wasn't even any warm temperatures here in the West Pacific a year ago, April 2024, and it was just cold water, and you see literally pulses. These are like cold water Kelvin waves, 1, 2, 3, 4, 5. And then look at this, boom, all of a sudden you hit March. And this is typically somewhere in the February, March timeframe. That's where you get the transition from El Nino to La Nina, or at least the early indicators of what's going to happen. You see, this is really a sign of easterly anomalies dissipating, upwelling, dissipating. The sun starts baking the ocean surface and water temperatures start building. Not from a Kelvin wave, just local heating, if you will. Notice the building reservoir of warm water in the west. Nothing epic, nothing huge now. You'd probably need another year or two before you're going to get anywhere near some sort of an El Nino. But the cool water volume limited to this one little area between 150 and 165, and at that only a half a degree to 1 degree below normal versus what was going on here. Certainly looks like La Nina is taking its last stand. Then we played the same game with ocean surface temperatures. This is the top, 5 meters of the ocean or whatever it is. South America, Central America, New Guinea, the equator's right there, date line's right there. California up here. One thing that draws your eye instantly is the buildup of warm water off Central America and Ecuador, and certainly more than 5 degrees north and south of the equator. Cool water, just ignore this. We're only looking 5 degrees north and south of the equator. Cooler water, way more dispersed than what it was even last week or the week before that. Now, a little bit more of it right here. But now let's go focus on what's going here and here. If you have high pressure, it rotates clockwise like this, takes trade winds blowing down the California coast, creating upwelling, and then those trades swing back this way. So some of this here is the La Nina cool pool. Some of this is the typical springtime upwelling pattern that occurs in this area. So this is not La Nina related. That's why they only say 5 degrees north and south of the equator. And even some of this, I would venture to say, is again that springtime high pressure pattern. The real La Nina cool pool, whatever it is this, which is looking darn near neutral. Let's go look at the trend over the past 7 days. Are the temperatures, or have they been warming or cooling over the past 7 days? South America, Central America, oh, you can't see it, 0. There, pull it in, 0 right there, the equator. Okay, you see certainly warming temperatures here in this area. A little bit of cooling along Peru. I mean, that's kind of typical this time of year as high pressure also builds here, creating upwelling. But you go from all this expanse, and if anything, the balance of temperatures are warming rather than cooling, in my estimation. All right, so what is the sea surface temperature trend doing? Nino 1.2 and Nino 3.4 sea surface temperature anomaly history. Nino 1.2, that's an area over the ocean. It's really right there by Ecuador and the Galapagos Islands. Temperatures in that area today are plus 1.183 degrees above normal, and you see they have steadily been rising since February 9th. So that's 2 months. That's not just the MJO, because the MJO doesn't hang for more than about 4 weeks over one spot in the ocean. This suggests a wholesale trend upward of sea surface temperatures in that area. Again, if La Nina was in control or building, these temperatures would be below the 0 line here, down in negative territory. But this is not the official El Nino monitoring region. This is the Nino 3.4 area. This is 5 degrees north and south of the equator, from a point south of California, 120 west out to 170 west, almost to the date line. The latest value, 0.494, right there. All right. Now, again, this could be the MJO, it could be springtime, it could be a whole bunch of things. But the key here is, if temperatures are half a degree above to half a degree below, that's considered normal, standard variation. Half a degree to 1 degree below normal is weak La Nina. 1 degree to 1.5 degrees is moderate La Nina. So this is, for the moment, neutral and has been more or less neutral since the beginning of March. So about a month. Sea surface temperature anomalies corrected. So there's the global temperature and climate change thing going on, right? And so the planet's getting steadily warmer. So what NOAA tries to do is say, okay, well, if the planet's warmer, instead of everything just being off the scale, they try to rescale it to make it fit in context with the current state of the environment. Anyway, in the Nino 3.4 region, this is the sea surface temperature anomaly. So what were we before on the previous chart? Like minus half a degree. But when you throw in the fact that it's a warming planet, we're actually plus 0.2 degrees above normal for the week of March 26, 2025. And you can see the trend. It's We went down to minus 1.1 degrees, but in general, we've been in weak La Nina territory, and now we're back to neutral. Neutral is minus half degree to plus half a degree. So what does the environment think is going on? We have a index called the Southern Oscillation Index. It is the difference in pressure between Tahiti, roughly on the equator in the Pacific, and Darwin, roughly in the maritime continent, Indian Ocean, close to the equator. Long-running sea surface pressure data. When pressure is on average lower in Tahiti, you create this index, the index goes negative. When pressure is higher in Tahiti, the index goes positive. Today's value plus 6.78. We were at minus 4.83 yesterday. See, we were quite positive there, but looking over the entire month, the value in general positive, suggesting La Nina is still in control. 30-day average. Now the MJO can affect this, right? Active phase, inactive phase pushing over Tahiti, bringing lower pressure can skew the data. So you can do a 30-day average, sort of see what's going on. Plus 10.31 today. Where were we? Well, if anything, we've been rising, suggesting pressure is rising. Is the tide turning? I'm not sure yet. 90-day average, this is your El Nino La Nina indicator, plus 6.75. Where were we a month ago? 5.16. It's going up barely. Let's look at this data on the graph. There we go, 30-day average. Neutral is plus 7 to minus 7. You can see the downward swings are the active phase, the MJO, upward swings, the inactive phase, the MJO. I'll pull this over so you can see. So here's today it says plus 20 here, but we're not really up there. There is differences between some of these indexes. But the general trend you see moving into La Nina territory in February. But that said, this was a late developing La Nina. Okay. I mean, it really, from all the data that we've looked at, it was La Ninas typically peak out around Thanksgiving to mid-December. This one really didn't get going until February, so it is not surprising to see the index still going up. This is a bit of a lagging indicator, but I think just looking at the sea surface temperature and looking at the data I'm looking at, I think the atmosphere is a bit slow to respond. There's things going on in the ocean. There's things going on in the projections and with winds and things that this index hasn't quite picked up on yet. Sea surface temperature forecast, sea surface temperature anomaly forecast from the CFS version 2 model for the official El Nino monitoring region, the Nino 3.4 region. All right, so where are we? April, well, this would be mid-April. So the last data point we had is plus a quarter, not even a quarter of a degree, a tenth of a degree, maybe not even that. And that was actually, this is actual data. The model had it somewhere down in here. So the model was like, what the heck? Where'd this warm water come from? That same sort of warm water, I think, that's building off of Ecuador is having some effect. Anyway, in April, it's forecast going down to half a degree below normal. Based on all the data I'm seeing, I don't see that. I see positive anomalies. So the model could be off yet again. Either way, as you get into June, we're supposed to be neutral. And then as we get into December, half a degree above neutral. Actually, somewhere middle of last week or something, it was up to like 0.75 or almost 0.8 degree above normal, which would be like borderline El Nino territory, but I don't think that's going to happen. But this still looking good. Oh, there's another version, the uncorrected version. Says the same thing, down just a little bit, but hovering effectively around neutral. And then there is the Pacific Decadal Oscillation. All right. And we don't look at this very often because it's a very slow moving thing. But the essence of it is the atmosphere goes through 20 to 30 year cycles where it's colder than normal, which is like like the MJO is to El Nino, La Nina. The PDO is like a long running El Nino or El Nino. So, and I'm just going to pick some dates here from 1896 into maybe 1909, roughly 20 years of warm And then we go into a cool phase from 1909 into 2025. And then from 2025, the index went positive to 1943, so about another 20 years or so. Then it went cool from 43 the whole way, more or less, to 76. So 30-year plus. Now notice, it means it's not always cool. There are these positive spikes in here, and those are El Niños and things that occur. Then from 77 to 98, all warm. In 98, you could literally, I mean, at least I was alive, I could see it happen. 98, boom, it's like someone flipped a switch. The oceans got way colder. The storm pattern changed significantly, and we have been cool ever since up to today. But I want to show you this. So this is the pattern from 2017. You see we were cool, lightly cool, and then we just started falling off a cliff in 21, 22, 23. This reading here, minus 3.8 in October 2024, one of the lowest readings ever recorded. Now, you know, do I believe data that goes back 100 or 200 years? No. I mean, they use tree rings. They're using ice core samples, all kinds of stuff. And it's gives you an approximation for what's going on. But no doubt we went cold here. A lot of this, I think, was all based on the Hunga Tonga volcano. Originally, they thought it hadn't pumped that much aerosols into the upper atmosphere because it was an underwater volcano. But then I saw some studies that said, no, that's really not true. And all this clearly sort of hints that that is, in fact, the case. But here is the deal. Starting January 2025, all of a sudden the index went to minus 1.28, minus 1.41 in February. Here we are in March, minus 1.12. 3 months, I'll even give it 4 months, is not a trend on a 30-year cycle. But maybe it's a step in the right direction. Maybe the aerosols in the upper atmosphere from Hunga Tonga are finally starting to get washed out, and we're moving towards a neutral pattern. So with that said, are the tides changing? Well, clearly from the perspective of winter moving to spring, for sure, that's changing. From the perspective of El Nino to La Nina, or La Nina to El Nino, probably not that, but maybe from La Nina to neutral, that would be a good thing. And then the longer term perspective from a cold PDO to a neutral PDO, if that were to happen, that would be the best news that I've had in 10 years. Literally. You follow these patterns that long. We've been waiting for it. Those of you that have been watching for years know that, we've been kind of sitting there waiting for the PDO to change, because once the PDO changes, even if it goes neutral, all of a sudden the jet stream pattern is going to change. The ocean currents are going to change. Fishing patterns are going to change. And at least from a surf and a water perspective into California and surf for Hawaii, I think that's a really good thing. Relative to surf in the Indian Ocean, maybe not so much, because a cold PDO really sets up like an El Nino pattern in the Indian Ocean, a long-running El Nino in the Indian Ocean, and you have a long-running La Nina in the Pacific. When the PDO flips, I think they flip too. So it would be not so good for the Indian Ocean from a surf perspective, but great for the Pacific from a surf perspective. Anyway, let's zoom back to, pull ourselves out of the 10-year cycle. What's happening for the next week or two? Southern Hemi swell looks like it's on tap after probably the last real north swell of the season fades out in California and Hawaii. And then we're off to the races. Now, not a whole lot forecast, but come on, it's April. Getting what it looks like we're going to get with a decent pulse of Southern Hemi swell into California over next weekend kind of thing. Not too bad. Take what you can get and be happy. And our fingers are kind of crossed that La Nina, the Modoki La Nina, is finally fading out, and maybe even the PDO will going to switch. That would be just too much to ask for. So I don't know. Let me know your thoughts on that. I know you all have opinions. I like hearing them. You keep me on my toes. Other than that, We'll see how it goes. It looks like winter's over. Skiing still there, but no fresh snow. That's all right. Corn snow is a good thing. All right, that's the video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, of course, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. Comments, questions, always welcome. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with a $sign on it. With that, we are done for this week. We'll do it again next week, same time, same channel. Thanks so much for watching.